This video is on Unit 2, Chapter 4 on complex numbers, lesson number 2, pure imaginary numbers. In your notes here, the first bullet says equations such as x squared plus 1 equals 0 have no real solutions. So mathematicians defined the imaginary numbers to represent their solutions. So I'm going to relate this to you in a little bit different way than that first bullet. Back in Algebra 1, you guys were learning about quadratics, and you learned how to graph them, and you learned how to solve by graphing. And in Algebra 1, when the parabola didn't hit the x-axis, you said at that point in time that there was no solution. There is no real solution. Because in Algebra 2, what we're going to learn about is the imaginary unit, the complex number system. So mathematicians defined the imaginary unit so that instead of saying no solution in this instance, there are no real solutions, but we're going to be able to define these imaginary solutions using the imaginary numbers in the complex number system. The second bullet says the imaginary unit I is defined as I equals the square root of negative 1. This is useful when working with square roots of negative numbers. The third bullet says that a pure imaginary number is written in the form bi, where b is the real number and I is the imaginary part. Steps for simplifying negative square roots. Step number 1 says to rewrite the square root of negative a as the square root of negative 1 times a. Break a down if it is not a perfect square in step 2. And then lastly, in step 3, you're going to simplify the radical, recalling that the square root of negative 1 is equal to I. So example number 1 says the square root of negative 9. Now 9, positive 9, is a perfect square. Negative 9 is not. So what I'm going to do is I'm going to rewrite this as the square root of negative 1 times 9. Now, you know that 9 is a perfect square. The square root of 9 is 3. So the square root of 9 is 3. And that leaves us with this square root of negative 1. Well, we just defined the square root of negative 1 as I. So this reduces to 3i. Number 2 is exactly the same. The square root of negative 196 is the same thing as the square root of negative 1 times a positive 196. And 196 is a perfect square. It's 14. So I've got 14. And then the square root of negative 1, again, is defined as I. So the answer to number 2 is 14i. Number 3 is a little different. So 5 is a prime number. It doesn't have a perfect square. But if I rewrite this as the square root of negative 1 times 5, the square root of negative 1 reduces to an I. But the square root of 5 is going to stay the square root of 5. So the answer to number 3 looks like this. I times the square root of 5. Generally, I put my I in front of the radical. I don't like for you to write things to the right of the radical because then sometimes it gets a little confusing whether or not you intended for a number to be under the radical or out of the radical. So I always put my numbers and my I's in front of the radical. Number 4 is similar, but it's not a perfect square. So for this one, the square root of negative 80, I'm going to break this down into negative 1. And then 80, depending on what method you're choosing to use here, 80, I'm going to use the y equal just for time's sake. I'm going to leave it as negative 1 times 80 underneath that radical. Now, you know and I know now that the square root of negative 1 is going to create an I on the outside of the radical. That's going to be on the outside of the radical. 80 is not a perfect square, so let's go to y equal. And we're going to do 80 divided by the x squared, like you learned how to do in lesson number 1. And it's going to reduce to 4 on the outside, 5 on the inside. 4 radical 5. And the 4 is going to go to the left of the I. So that goes back to this bullet right here where we talk about BI. The real part is going to go in front of the I. So 4I, 4 is a real number. It goes in the front. But again, radicals are kind of weird here. We want that to go to the right of the I. Same thing on number 5 and number 6. Let me do one more. Number 5, we're going to rewrite this as the square root of -1. I'm just going to leave it at 32. Again, just to be quick, I'm going to go back to my y equal and do 32 divided by x squared. And that's going to be 4 times the square root of 2. So the 4 goes outside with the I, and the 2 stays under. So 4I radical 2. And again, you are more than welcome to use the other method for simplifying those radicals. I kind of go back and forth. On numbers that are small like that one, I probably would have, if I were doing it, would have done it by hand. Because I could. The larger numbers are a little more difficult. Number 7, just really quick. Number 7 and number 8 are different than the rest because they have that coefficient in front. Same thing with 9 and 10. There is a number in front. So number 7, I'm gonna rewrite this as 4 times the square root of -1 times 36. Now 36 is a perfect square. So the square root of 36 is 6. So we have 4 times the 6, and then of course the square root of -1 is the I. So 4 times 6 times I. So 24I is your answer on number 7. Let's look at number 8 really quick. Number 8 has 5 times the square root of -18. So rewriting this is 5 times the square root of -1 times 18 is one that's a small number. I can quickly identify this as 9 times 2. And I don't need the y equal aspect of my graphing calculator. The square root of 9 is 3. So I would have 5 times 3 times the I, square root of negative, this right here, square root of -1 is I. And then the 2 is going to stay under. So I have 15I times the square root of 2. And I want to show you number 10 really fast. -2 times the square root. Again, we're going to break that into -1. 45 is 9 times 5. Square root of 9 is 3. So I have -2 times 3. The square root of -1 is I. And then your leftover stays under the radical of the 5. So -6I radical 5 on that one. Let's keep going. Number 11 and 12 are the same. So I'm going to skip those. So the steps are exactly the same for those two. I want to get down to the powers of I. Powers of I. So there is a pattern that is created here. If we do I to the first power, which is just the square root of -1, we still get I. And if we take I and we square it, I is equal to the square root of -1, and we square that, you're just going to get the -1 because the square and the square root cancel each other out, leaving you with a -1. Well, I cubed is a combination of both. So it's the I squared, which is -1, times I, which is I. So we get -I. I to the fourth power is the same thing as I squared squared. Well, we know that I squared is -1, and when we square that, we get a +1. Now, here's the interesting part. Here's where it gets interesting. When you get to I to the fifth power, I to the fifth power is the same thing as I to the fourth times I. Well, I to the 4th is 1, and I is just I, so we get a positive I again. I to the 6th power is the same thing as I'm going to use I to the 4th times I squared. So we have 1, I to the 4th is 1, I squared is -1, and you get -1. I to the 7th, I'm going to use I to the 4th again, times I to the 3rd, because 4 plus 3 is 7. I to the 4th is 1. I to the 3rd is -I, so we get -I again. And then I to the 8th is I to the 4th squared. So I to the 4th is 1, squared is still 1. Now, what I hope you have noticed at this point is these answers are the same, because that's the pattern. After every 4th power, it repeats. So I can sit here and I can tell you, I know that I to the 9th power is I to the 10th power is -1, I to the 11th power is -I, and I to the 12th power is a +1. And here's how I remember this and how I usually tell kids to remember this. If you can remember this little mantra of I won, negatives are in the middle, then you've got the I to the 1st power, I to the 2nd power, I to the 3rd power, and I to the 4th power memorized. I won, negatives in the middle. So to use this pattern, you're trying to figure out how many 4s are in the 15. For number 13, your exponent is 15. So how many 4s are in 15? So you'd have 4, 8, 12. So I to the 4th 3 times gives us 12 of the 15, right? So then that leaves 3 more. I to the 4th is 1. 1 raised to any power is just 1. And then I cubed is -I. So that gives us a -I for an answer. For 62, how many I to the 4ths are in 62? Let's see. 62 divided by 4. It's not going to go evenly. It's 15 and something. So I to the 4th times 15, raised to the 15th power. That's going to be 60 of the 62 exponents. So I need 2 more. So I to the 4th to the 15th power is just 1. So basically, the reason why I'm using I to the 4th is because I know that I to the 4th is 1, and I'm trying to get rid of all just the plain 1s and figure out what my leftovers are. I squared, if you go back to the chart, I squared is -1, and 1 times -1 is -1. All right, so we're going to use this as we go through the product of pure imaginary numbers. We want to simplify the expressions below. Number 15 says 4i times 7i. Well, 4i times 7i, i's work kind of like variables. So when I take 4i times 7i, I'm going to get 28i squared. And I squared is equal to -1. So this is 28 times -1, which is -28. Number 16, we got 4i times 2i times -9i. Well, I times I is I cubed. Well, that part I got. 4 times -4 times 2 times -9. 4 times 2, -4 times 2 is -8. -8 times -9 is a +72. And then I cubed, I won, negatives in the middle. I cubed's -I. So this is 72 times -I, or -72i. For number 17, we have 2i cubed times 5i. So 2i cubed, 2 cubed is 8. I cubed is just I cubed, and then I'm going to multiply that times the 5i. So then we're going to multiply the 8 times the 5 and get 40. And then I cubed times I, remember to add those x when you're multiplying, you add exponents, so this is going to give me I to the 4th power. I to the 4th power is 1. So I've got 40 for my answer on number 17. So we're doing this all in our head. We're using our head. Number 18 says I times the square root of 3 squared times negative 8i squared. All right, so I need you to put your thinking cap on. When you take a square root and you square it, we've talked in class about the fact that squares and square roots are inverse functions of each other. They're inverse operations and they cancel each other out. So when you square a square root, they go away and you're just left with a number. So when I take I times the square root of 3 and I square it, I get 3i squared. I'm going to multiply that times when I square negative 8. Negative 8 times negative 8 is a positive 64i squared. Now I need to take 3 times 64. 3 times 64 is 192. So I get 192. I to the add your exponents, 4th power. And you now know that I to the 4th power is a positive 1, which gives us 192 for our final answer on number 18. Last two, number 19 and number 20. These are a little different. So normally I would tell you to just multiply the numbers underneath, but they're negative. We can't do that. You have to take the I out first. And normally I would rewrite this as the square root of negative 1 times 18. But I think you get that when you have a negative underneath, it's an I on the outside. A negative underneath is an I on the outside. So now what I have is multiplying outsides together and insides together. I times I is I squared times the square root of 180. 18 times 10 is 180. That's going to be, I think it's 36 and 5. Let's double check. 180 divided by 36. Yes, 36 and 5. So I've got I squared times the square root of 36 times 5. I squared is negative 1. And then the square root of 36 is 6. So if I squared is negative 1, negative 1 times 6 is negative 6 times the square root of 5. Last one, number 20. Again, we're going to take the i's out first. So I times the square root of 24 times, I forgot the I square root of 3 times I square root of 2. I times I is I to the 3rd power. And then I'm going to multiply 24 times 3 times 2. 24 times 3 times 2 is 144. Love that number. The square root of 144 is 12. And then what is I cubed? I cubed is I1, negatives in the middle. It's a negative I. 12 times negative I is negative 12I. So there are your notes for Chapter 4, Lesson number 2 on pure imaginary numbers.